topic is naive-Bayes classification, and supervised learning can be studied from probabilistic point of view, and a probabilistic point of view will study naive-Bayes classifiers, which is a linear model, and the basis for a naive-Bayes classifier is Bayes theorem. And it is. Can you able to see this PDF? All right. So first we'll study the probabilistic model, wherein we need to identify or determine the class Cj or the class value given the attributes, and the prediction is done based on the higher probabilities, that whichever class is getting the maximum probability, that is assigned to the text example. Right. So applying the Bayes rule, what is this? Posterior probability. Posterior probability is equal to conditional probability into prior probability by evidence. So to learn the probability of conditional probability and prior probability, we use maximum likelihood estimation. So what is this formula? The below formula is maximum likelihood estimation. That is the number of documents that are classified as CJ by total number of documents. I'll repeat. The maximum likelihood probability is the total number of documents that can be classified as class CJ by the total number of documents. So as of now, see, this is the evidence property of this total number of documents. When you take total number of documents for each and every conditional probabilities, the total number of probabilities as it remains same, we are considering only the conditional probability and the prior probability. Now, we have this conditional properties. We'll calculate the probabilities for each and every attribute with respect to the given class. Okay. In the previous, what is our formula? The conditional probability into prior probability. And now here we are finding the probability of each and every attribute and its possible values. Now we need an assumption that all attributes in the data are independent to each other. So we assume that we need to find the probability of the attribute of the given value, that is the attribute A1 given the values of other attributes and the class value. So this probability of each and every value of a particular class J is the product of the probability of attributes of every value. ఈ ఫార్ములాస్ ఇవన్నీ మీకు ఎగ్జాంపుల్స్ తో అర్థమవుతుంది. దట్ ఈస్ ద ప్రోడక్ట్ ఆఫ్ ఎవ్రీ వాల్యూ ఈస్ టేకెన్. So the final naive-Bayes theorem, we need to estimate the class value given all attribute values. That is given by ఇక్కడ మళ్ళీ ప్రీవియస్ ఫార్ములానే. What is this? Conditional probability into prior probability, this value you got as individual values that we are substituting here. Now we can estimate the values. And once the test example is given, the maximum value of the probability for the given class is considered as a class value for the test example. So let us see the example. So I have two attributes A and B, and the class, the third column is the class, and it contains two values, true and false. So the probability of the class having the value true is 5 by 10, which is equal to 1 by 2. Similarly, the probability of class F is also 5 by 10, which is equal to 1 by 2. Now find the probability. We are going to find the probability for each individual values. Okay. So now calculate the probability for attribute A when value is equal to M. We have two values, sorry, three values, M, G and H. So given the class value is equal to true and A, we need to find the probability of A is equal to M. So true values are 5, and when out of 5 values, 5 records or 5 examples, 2 records are having A is equal to M. So that is 2 by 5. Is it clear up to now? Right. So similarly, calculate for A is equal to G value and A is equal to H value, and B is equal to B is equal to S, and B is equal to Q. Okay. Find all the probabilities. Now our test example is A is equal to M, B is equal to Q. We need to find C value. For finding the C value, we need to find when probability is of C is equal to T and probability when the class value is equal to false. So it's the product of that all the values. So class value true unnappudu, what are the values? For A is equal to M and B is equal to Q. True unnappudu 2 by 5 and B is equal to Q, true unnappudu 2 by 5. 2 by 5 into 2 by 5 and what is 1 by 2? The probability of C is equal to T. That is equal to 2 by 25. Is this point clear? Doubts ఉన్న వాళ్ళు ఇక్కడే అడగండి. Any doubts? Okay. Similarly, calculate for probability is equal to C is equal to F, and we are getting 1 by 25. So out of these two values, you need to take maximum probability to find the class value for the text example. So the maximum probability is 2 by 5, which is having the class value true. So we are assigning true for our text example. So to practically to learn about naive-Bayes classification, we need to address these issues, that is numerical attribute, zero count and missing values. Numeric attributes. Naive-Bayes learning assumes that the attributes are categorical. And this, when you have numerical attributes, that has to be converted into categorical values. And previously, in previous classes, we have seen how to convert the numerical attributes into categorical values based on some range that is called as a discretization. I want someone to explain zero count. Zero count. Anyone? Ah, ah. Whenever we take AI, it is not Srichena. Sorry. Very good attempt, Amma. Right. నేను ఇప్పుడు ఒక ఎగ్జాంపుల్ చెప్తాను చూడండి. If you take this probability, okay, we are taking the probability of each and every value. Say, for example, A is equal to M. This is my test case. If A is equal to M is not there in my training set, then what is the probability of that value? What is the probability of having that value? A is equal to M? 0. Very good. So, as it is the product of all the attribute values, if one value becomes 0, everything will become 0. Is this point clear? If my test case contains any value, a particular attribute value that never occurs with the class value in the training set, then that probability will become 0. If the probability becomes 0, then the entire calculation for the class value is equal to true will become 0. Okay. To avoid such types of problem, we use a technique called smoothing, wherein we will instead of simply we are using this formula, we use another formula called as Nij plus lambda by Nj plus lambda Mi. According to the textbook, it's not lambda Ni, it is lambda Mi. Remember that. As it is PDF, I am unable to change it, but you correct it, it's Nj plus lambda Mi. Where Nij is number of examples that have both AI, that is capital AI is equal to AI, and the class value C is equal to Cj. And Mi is the number of the number of values of attribute AI. And what is this lambda? Lambda is some manipulation factor which is commonly set to lambda is equal to 1 by n. And when you set this lambda is equal to 1 by n, it is called as Lidstone's law of succession. And if you set the lambda value is equal to 1, then it is called as Laplace law of succession. I'll repeat. When lambda value is equal to 1 by n, it is called as Lidstone's law of succession. And when lambda is equal to 1, it is called as Laplace law of succession. And in IRS terminology, this smoothing technique is called as, according to its value name and term, adjustment factor. So, we are adjusting the value so that it does not become to 0. So different authors use different terminologies. But this is web mining, we use the word smoothing. This technique is called smoothing, and the factor you are using is the adjustment factor. If you have any missing values, that is to be ignored. The advantage of Bayes classifier is easy to implement, very efficient, and we can obtain good results for many applications. And the main disadvantage is we are assuming that the attributes are independent to each other, and this is violated, then you will get incorrect results. Naive Bayes for text classification. ఈ టాపిక్ అయిపోయిందా IRS లో? Okay. No. There are n number of documents on the web, and these documents have to be classified automatically. And whatever techniques we are discussed previously, that is naive-based classification, may not be appropriate for text classification on the web. So it has to be adjusted somewhat. The naive-based classification is adjusted. But the idea is similar to the preceding one. So we are using the probabilistic model, and that probabilistic model we are using for classification of documents is called as generative model. Each document is generated as some parametric distributions given and it is governed by a set of some hidden parameters. So the generative model makes two assumptions, that is, the data is generated by mixture model. We'll see what is this mixture model and the mixture component. And there is one-to-one correspondence between mixture components and the document class. So example direct వెళ్ళిపోతాను నేను. See. Each class is represented by a distribution. This is one distribution and this is second distribution. Okay, this distribution is pointed based on the documents. Documents of one particular, the first curve is documents of class 1 and the second one contains documents of class 2. And by seeing this diagram, we can say that why we are using this model. We are using this model to find that if there are any clusters which has labeled with two class names. So if you see this curve, it's overlapping here. So it is this overlap contains the class values of both class 1 and class 2. To see that whether any group or any documents having two class names or any group that has no class, this model can be very useful. So again, coming to my definition, now you can understand. So one curve is one component that is correspondence to a document classes. So what is a mixture model? A mixture model is the data with number of statistical distributions, and each distribution is a mixture model, is also called as mixture component. This one distribution is called as a component. Up to here, is it clear? So this document or the components, collection of documents forms the curve. So how collection of documents and what how you will draw this curve using some parameters. That parameters are denoted with theta, which has mean and standard deviation. And what is the this theta representation? And this is also theta, this symbol. Okay, one is big theta and another is small theta. So let the number of mixture components in the model be k, and the jth distribution have the parameters theta j, and the set of these parameters is represented with the small theta, which consists of phi of 1, phi of 2, and the theta values. What is this phi values? Is the mixture weight values. And when you take the weight values are biased by dash. Chepan. Whenever you take, see, there are two types of representations. The data, when you take the collections of documents, the documents can be represented using binary model or vector model. Vector model lo kuda malli binary data తీసుకోవచ్చు, or you can take weights. That is nothing but term frequency. Right? నేను చెప్తుంది ఐడియా ఉందా మీకు లేదా? ఉంది కదా. So it is biased by when you take the term frequencies. Term frequencies తీసుకున్నప్పుడు మెయిన్ ప్రాబ్లం ఏంటి? అదే ఓకే, ఇట్ ఈస్ రిట్రీవ్డ్ ఓకే, but the term frequency, if you take, it is biased by document length. If the document length is more, you will get entama Sai Krishna, you are saying something. So if the document length is more, obviously the term frequency is more, so it is biased by the document length. So to avoid that, instead of term frequency, we use term frequency inverse document frequency, IDF. Sorry, no IRS class. So it's the mixture weights of the mixture components. So how, with these parameters, how the model will generate the documents, required documents. That means classify the documents. Due to this one-to-one correspondence, each class is a mixture components, and the mixture weights are considered as prior probabilities. So the mixture model generates each document by first selecting a mixture components according to the class prior probability. Then once the class, according to the class probabilities, it selects the mixture components, it generates the document DI according to these parameters, according to the formal parameter probabilities. అంటే ఇందాకటి డెఫినేషన్స్ ని మళ్ళీ కొంచెం slightly it has changed. The naive-Bayes classification formula has changed like this according to the parameters. Sorry. Is the PDF visible? Multinomial. So as we are taking the number of documents, this is also called as a multinomial distribution, and the words are taken from the given vocabularies, that is given set of data. And words are the documents. This is the main points. In previous session, what is our assumption? The attributes are independent to each other. And here we are assuming that the words in the document is independent of context given in class labels. See, in a our class label is, say, for example, data mining, and I am taking a document. I am not retrieving the words which are relevant to class label data mining. అంతే కదా, డేటా మైనింగ్ కున్న I am retrieving all the unique words which are there in the document, and I am classifying according to the class labels. Is that point clear, or shall I repeat? Clear? Okay. And even the probability of word is independent of its position in the document. We are not considering the position in the document. But sometimes when you are want to search the term, The position is also required. Tell me the example. Tell me one such word where the position of the words are important. Say, for example, I am searching for the word United States. United States is the country. So the word United and States should appear side by side. Other, for example, States United అనుకోండి. It telling about the unity of the states. The order is different when you are using co-terms. United States, దాని మధ్యలో ప్రాక్సిమిటీ 0 ఉండాలి. So they should occur one after the another. In this case, the position is required. Right. So here my assumption is the probability of words is independent of its position. Slides. So using probability function of multinomial distribution, this is the formula where ni is number of times that the word occurs in the document. The final document is given. Formulas గుర్తుంచుకోండి. ముందుకెళ్తుందా వెనక్కెళ్తుందా? Right. So the probability of the word given the class Cj is given by sigma of I is equal to 1 to mod t nti, the condition prior probability, but by the summation of all the probabilities where the document is given. You need to find the probabilities of class Ga given the document I. So what is Lidstone law of succession or Lidstone smoothing? If you take the value as 1, so given a test document Di, from the previous equations, we got this formula, and we'll estimate the class values, and the maximum of the probabilities is taken. So you need to remember these formulas. So what is our main assumption? That the attributes are independent of each other. Or if you are taking the test classification using naive-based classification, what is our assumption? That we are not considering the position and we are not taking the words with the context of class value. But these are somewhat violated in practice, but it should not be violated more. And despite of the violation, naive-based is a promising classifier. Support vector machine and k nearest neighbor is not in your syllabus. So we'll move on to the next topic. We are done with supervised learning. What is the next topic? Unsupervised learning. Let me share that one. Give me 1 minute of break. analysis. There's a difference between supervised learning and unsupervised learning. Supervised learning will have a class labels, whereas unsupervised learning does not contains a class label. So what comes under supervised learning? Classification and association, because even association does not have any class labels. So the general association is mining can be categorized under supervised learning. So first, the basic concepts. So in supervised learning, we'll discover the patterns which have our target value, that is class, and these patterns can be used to learn the future examples. But whereas in unsupervised learning, you don't have any target values or the class labels, but we want to find some structure in between this data. What do you mean by structures?
Pattern.
Structures in the, okay. Every answer Jason, it's not Sai Krishna.
Harshit, ma'am.
Huh?
Harshit.
Okay, right. So we want to find some relation between these data objects. That relation will find, that means we'll find some dissimilarities between the data or similarities or dissimilarities. To find the similarities or the dissimilarities, what metrics we will use? How will you find the similarities?
Proximity.
Huh?
Proximity, ma'am.
Proximity and nearness, how you will find?
Distance between the.
Yes, the distance. The most popular distance method you use is
A means.
Euclidean distance.
Oh yeah, yeah. Sorry.
Right. So everyone knows about clustering. So I will read this. So you find the similarity groups and which is called as clusters. It groups the data instance that are similar to each other into one cluster and all the dissimilar data points into other clusters. And this clustering is called as unsupervised learning because there are no class values. So this is we have plotted the different data points in the graph, and it has grouped into 3 clusters. Why clustering is required? Clustering is, for example 1, clustering is required to group the people according to the sizes so that the tailor can stitch the clothes according to their size. Because you cannot go for a generalized size, because generalized size may not fit for all the customers and it may leads to the loss. And the second example, in target marketing. This example I have given many times. Tell me an example for target marketing.
If any product is to be sold for only children or only youth or maybe youth and old age.
Very good. Yes. Next. In text, I have n number of documents, and I don't know this which documents belongs to which group. So in that case, I'll group the documents according to their similarities. So it is the most utilized data mining technique. and it is used in almost every field, that is medicine, psychology, botany, sociology, libraries, etc. And due to rapid increase of online documents, text clustering becomes important. There are two types of clustering algorithms, that is partition clustering and hierarchical clustering. Clustering needs similarity functions, that is the distance function. And when you are using, when you are constructing a cluster, you will see intercluster distance and intracluster distance. What is intercluster distance? The distance between two clusters. And intraclusters, the distance between the data points within the clusters. I think the definition is cleared between intercluster and intracluster. Or, or shall I repeat? No need. Okay. So when calculating the distance, you will see that the intercluster distance is maximum and the intracluster distance is minimum. And the quality of clustering results depends upon the algorithm, the distance function, and the application you are using. K-means algorithm. Who will explain K-means algorithm? Myself. Okay, right. చెప్పండి. Very good. అంతే. First, at the first stage, we'll take k random points and we'll calculate the distance between each and every other document or other examples with this k data points. And whichever, sir, for example, we are taking the test example T1. We'll calculate the distance between T1 and this k points, k documents. Whichever may be the nearer, we'll assign that T1 to that point. Similarly, we'll check for all data points. Then what is the, after calculating, this is the first stage. After calculating, what you'll do, what is the next stage? We'll calculate the mean of these new clusters and we'll form the new clusters again. Then what is the stopping criteria? Board unte easyga visualize change. Right, tell me, what is the stopping criteria?
Ma'am, do you mean threshold?
This you are go on iterating kada. First you are selecting k points and you are calculating the distance between these k points and other data points. Then I'll directly, I think I have 1 minute. See, okay, now see, you are first you are selecting these two data points randomly. K is equal to 2. Okay, and you are calculating the distance between each and the data point with this k values, and you are forming the clusters. Once the cluster is formed, you calculate the mean values of this cluster and the mean value of this cluster, and find the distance between the mean value between other data points, and a new cluster is formed. Okay, so the iteration continues. So up to so even in classification there is some stopping point is there. Even this in clustering, what is that stopping point? When the mean doesn't change, see, there is no reassignment of data points to different clusters or no change of centroid. And the third one is the sum of squared error is minimum, that means even if you calculate the sum of square errors and the value is very slight, then also you will stop the iterations. So these are the 3 points. Is that point clear? So what is the algorithm? At the first stage, you are choosing the k data points, and for each data point in the data set, compute the distance from these data points to each centroid. Here at the first stage, the centroid is nothing but the k data points that you have chosen, and assign the x to the closest centroid. After the clusters has formed, recompute the centroids using the new clusters until the stopping criteria is met. So the stopping criteria is no reassignment of data points to the clusters, or there is or minimum or no change in centroids, or the sum of the squared error is minimum. Any doubts? This is the k-means algorithm is used for any applications where the mean can be defined. So the mean is given by mean value ఎలా calculate చేయాలో తెలుసు. All the data points for a given value Cj, the number of counts of the class values or the number of documents. So once the mean value is calculated, you will calculate the distance between the mean value and the data point using the Euclidean distance, and the Euclidean distance formula is given by xi minus mi plus xi minus x2 minus m2 so on whole square, sorry, xi minus mi whole square plus x2 minus m2 whole square plus xn minus mn whole square under root. Disk version of k-means. See, as the data is more, you cannot keep all the data in temporary storage. So what is the solution for this? Inside you'll take only the subset of the data and you form the clusters for that subset of the data, and you transfer it to the disk, and the process repeats. That means you create very small clusters, very tight clusters, which have the minimum data points. And once the minimum data point clusters are constructed, you combine these clusters. But so what is the stopping criteria? What is the iterations? How many iterations will go? In practice, the limited is less than 50, which is not so appreciable. So for that, the best method used for disk version of k-means is Birch algorithm. Have you studied the Birch algorithm in data mining? Yes, you have studied. So Birch algorithm comes under which clustering technique? Hierarchical clustering. So choose k data points and initialize a vector with 0 and initialize the number of points. For each data point, the minimum distance is calculated and assign that value to the cluster. So at first, each data point is taken as a cluster and you merge these clusters according to the distance. The strengths of K-means algorithm, simple to use, and the time complexity is given by big O of TKN, where T is number of iterations, K is number of clusters, and N is number of data points. So K-means algorithm is considered as linear algorithm as it has small values. And local optimum and global optimum. What are these local optimums and global optimums? So you are taking the data from the disk, only the subset of the data from the disk to the local systems. Then in the local systems or in temporary memory, you are optimizing the data. So it is called as local optimum. And once these smaller clusters are formed, again you are transferring into the disk. And there you are combining into the larger sets. And local and global అనే వర్డ్స్ ఎక్కడ యూస్ చేస్తారు చెప్పండి మెయిన్గా ఎక్కువగా ఇన్ డిస్ట్రిబ్యూటెడ్ సిస్టమ్స్ in distributed you have if you have entire global entire data only the subsets are given to the local systems. In the local systems it is processed and it is given to the master systems, and the master will decide which clusters to combine. K-means algorithm. The K-means algorithm is applicable if you can able to define the mean, and for categorical data you'll use mode rather than mean, and mean use chechu. But what is the problem with mean if you use mean?
When the distance is too large, the mean gets weakened. Like distance between 2 points is too large, the mean may fall very distant from the most points.
Mean ante it's average, right?
Yes, ma'am.
So it the data will get biased. Ante for example, I want to find the employees who is I want to find uh, the average salary of the employees for a given organization. For example, I have 2 employees and one employee is getting 50,000 salary and one employee is getting 500 rupees salary or 5,000 rupees salary. What is the average salary? Say nearly
27,500. 27,500.
అంటే average గా the organization is giving 25,000 salary to the employee. Is it right?
Yes, ma'am.
One is getting too less salary and only one so 10 employees ఉన్నారనుకోండి 10 employees కి నేను 500 10 లో 9 employees కి I'm giving 500 and for only one employee I'm giving 25,000. Then I'll portray that I am, on the average, I am giving salaries to the employee 25,000, which is wrong statistics. It is when you use mean, the value is biased towards the higher value. Can you able to get it?
Yes, ma'am.
Yes. So in most cases, using mean is not appropriate. So we can go with median or mode. Mode is used mainly for categorical data. And specifying the k value is also difficult. How many clusters you want to make? How you'll decide? That is also difficult. And the algorithm is sensitive to outliers. And once, if you see in this example, so though this data point is within the cluster, it is far away from this data point. So I can consider it as outlier. So as it is far away, I am restructuring my cluster, and it now this point is out of cluster. When outlier occurs, what is the solution?
Removing outliers.
Yes, remove that example, remove that record. So to deal with outliers, remove some data points in the cluster process. Another method is to perform random sampling. Randomly select some of the data and cluster them. The same thing. And say when you cluster the data, the main thing is you are taking the initial k values, right? You start clustering with by taking different initial values and then check whether you can get reduct from the outliers or not. And another weakness is K-means algorithm is not suitable for hyper episodes or hyperspheres. So if the data is like this, you cannot cluster the data. So despite of its weaknesses, K-means is most popular algorithm, and there is no clear evidence that any other clustering algorithms will perform better than this K-means algorithm. And comparing different clustering algorithms is very difficult task because no one knows that which is the correct cluster, because according to the problem statement or according to your data set, some cluster may be better than other clusters. It depends upon the data set you are choosing. Representation of clusters. So this we'll see in the tomorrow's class. Thanks for the day. And do not leave. Let me check the attendance. 21. Okay. Attendance